Right, on this side, we're not only proving the triangles are similar, we're then solving for x. Let's be clear that we cannot solve for x using a proportion unless we know the triangles are similar. So you need one to happen before the other, so we're always going to do the proof first. So let's look at what we have in this first triangle, and we notice that it is a parallel symbol given. So this right here shows parallel and right here. So when you have parallel lines tell us that alternate interior angles are equal. We could use that one right there, or we could use this one right here, or we could use both. We also have a set of vertical angles here. All we need to prove two triangles similar are two angles, or one angle and two sides, or three sides, right? So we're going to shoot for two angles over here. You can mention any of the two angles. So I'm going to say angle E is congruent to angle N. And then I'm going to say angle C is congruent to angle G. And the reason for that is alternate interior angles are equal. You also could have used the vertical angles. I don't care which ones. Now we have enough for similarity. So we say triangle EUC is similar to triangle NUG. Let's try to fit this better in here. Okay, and those are similar by a similarity theorem. So now that I proved the triangles similar, check, I can now go solve the proportion. So pause the video and try to set up the proportion, and then let's see how you did. All right, I'm going to go, this corresponding side is to this. So x minus 1 is to x plus 5 so if I went left to right, I have to go left to right with the other side. So left is to right as left is to right. We now cross multiply. 5 times the quantity x minus 1, and then 2 times the quantity x plus 5, and we're going to solve this. Now, if you set up the proportion a different way, there's multiple ways to set up this proportion, it's okay as long as you got these two things when you cross multiplied. So 5x minus 5, 2x plus 10. I'm getting a result of x equals 5. How'd you do? All right, pause the video, try the next one, see how you do. All right, I've got these parallel marks again. That means I have some angle relationships. Well, what's in this picture this time? Corresponding angles are equal. Could be that one or this one, doesn't matter. I can use one or both. I also have this reflexive angle where the angle equals itself. So it's up to you. I'm going to say angle W is equal to itself by the reflexive property. And then I'm going to say angle WNO is congruent to WBR. So which two angles were those? That was this angle here and this angle here in this corner. And that's I like to write the little parallel lines. Parallel lines tell us that corresponding angles are equal. Okay, I've got my two angles. I've got enough for similarity. Triangle WNO is similar to triangle WBR. And that is by a similarity theorem. Okay, did I prove the triangles similar? Check. Now I'm able to go do the proportion because they're similar. So pause the video and try to set it up on your own. Let's see how you do. All right, notice if I'm going small is to big, I've got to consider the entire side length of x plus 6. And over here on this side, the entire side length of 3 plus 5, which is 8. So I'm going to go small is to big as small is to big. See if you can take a minute to understand how that came about. Now we cross multiply. And I'm getting a result of x equals 9. All right, on this next one, I've got one angle and two sides. We do have enough for triangle similarity. Picture it like this. This side's going to correspond to this side, and this side's going to correspond to this side. And we have the included angle as equal. So let's go right up the proof. We can say RO is to MI, and then we can say RG is to MC. And when I reduce 15/9, can you see 3 goes into 15 5 times, 3 goes into 9. So we do have the ratio of the two sides. Then there's angle R, congruent to angle M. Here, this is ratios of corresponding sides are equal. And down here it was given. So we have enough for triangle similarity. Sorry, I'm squeezing this in down here. Triangle ROG is similar to triangle MIC by SAS similarity theorem. Okay, now that I proved the triangle's congruent, check. I'm sorry, not congruent. Similar, check. Now I can go and do the proportion. Only if they're similar can I do a proportion on them. And I can use either side on this one. I'm going to go big is to small as big is to small. So can you see what I just did there? I went like this. Big is to small as big is to small. Did that work for you? All right, go cross multiply that. See how you do. I'm getting the quantity, 3 times the quantity x plus 8 times 5 times the quantity 2x minus 10. 3x plus 24, 10x minus 50. Let's minus the x's. Let's add the 50. All right, does 7? No, it doesn't go in even. I'm rounding to 10.57. Okay, that's giving me a weird answer that I don't remember. Let me just double check my work here for a sec. X plus 8 is to 5 as 2x minus 10 is to 3. 3x plus 24, 10x minus 50. Make sure you can see that this is a 0 here. My writing got scribbly. Then we minus through 3x, and we added the 50. 50 plus 24 is 74. Yep. All right, I'm getting that funky answer. How'd you do? All right, next one. It's looking like a side angle side. Because this side compared to the small side, this side compared to the small side, and then this included angle down here, side angle side. So let's go prove it. Angle H congruent to itself. By the reflexive property. And then we could say side HU compared to HA. So 20 is to 12. And then side HY, side HN, 12 is to 15. Wait, 20, hang on. Okay, hang on. All right. HU compared to HY is 20 is to 25. Where does the 25 come from? The whole side length. Just like this bottom one is 15. All right. And then we'll do HA is to HN, or 12 is to 15. So what goes into 20 and 25? How about 5 goes in 4 times, 5 goes in 5 times? What goes into 12 and 15? How about 3? 3 goes in 4 times, 3 goes in 5 times. Because the two side ratios are the same, boom, we have side angle sides. So triangle HUA is similar to triangle HYN. And that's by side angle side similarity theorem. And what do we put for this? We put ratios of corresponding sides are equal. Okay, now that I proved the two triangles similar, check, I'm able to go solve the proportion, only in that order. So I'm trying to solve for this x, so I could go like small is to big, like left is to right. Now I want to go small is to big on the sides, and you can use either set of sides. I can use 12 and 15, or I can use 20 and 25. It's up to you. So I'm going to use small is to big because it's smaller numbers. So 10 is to x minus 7 as 12 is to 15. Go ahead and cross multiply. I get 150 equals 12 times the quantity x minus 7. 7 times 2 is 14, carry the 1. Okay. Add 84. What is that? 234. Double check my math for me. 150 plus 84. Grab a calculator. Yeah, 234 divided by 12. 19.5. All right. Last two. All right, for this one, let's do angle, and then you can use the corresponding angles from the parallel lines right here. So we're going to use angle. So I can say angle F is congruent to angle ARS, and that's by parallel lines tell us that corresponding angles are equal. And then angle A is congruent to itself by reflexive property. And then triangle ARS is similar to triangle AFE by angle similarity theorem. All right, let's go do, now that we proved the triangle similar, check, I'm able to go do the proportion. So we're going to say x plus 2, small side, is to whole big side, x plus 2 plus 7. That's this whole side. As small is to big on the other side. So that's a 16 for the small and a 24, you see it right here, for the big. All right, so let me show you those again. I went small is to big as small is to big. And that really makes an x plus 9 on the bottom. Does that make sense? So we go 24 times quantity x plus 2, 16 times quantity x plus 9. What is that, 144? Somebody check me on that. All right, 24 minus 16. And then subtract 48 to the other side. All right, let's grab a calculator here. All right. So I get a result of x equals 12. All right, last one. Let's go look over here. 3 side ratios. Can we flip this around to have corresponding sides? So, for example, this longest side is going to go with the 24. The second longest side is going to go together, and then the shortest side. So let's see if these side ratios work out. So ON, I'm going the purple side first, compared to WI would be 27 over 18. Let's do NJ, yellow side, and CI, so 36 over 24. And then let's do the green sign, OJ, CW is 18 over 12. Go double check my numbers here. Purple side, 27 is to 18, 36 is to 24, 18 is to 12. Okay, let's reduce it. 9 goes into the top two. 9 goes in 3 times, 9 goes in 2 times. 12 goes into the next two. 12 goes into 36 3 times. 12 goes into 24 2 times. 6 goes in 3 times. 6 goes in 2 times. Hey, look at that. Ratios of corresponding sides are equal. We have enough for triangle similarity. Triangle NOJ is similar to triangle. Okay, so I'm going along the purple to the green, so IWC. And that's by side, 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 similarity theorem. All right, we just proved the triangles are similar, check. So now we're able to do the last proportion. And I just realized we don't even have to do a side proportion. We just have to do the angles, the corresponding angles are equal. Yay, that's way easier. So 5x plus 8 is equal to 103. 5x is equal to, is that 95? All right, grab a calculator. 95 divided by 5 is 19. How'd you do?